I'm Marcia McNutt, the National Academy of Sciences president. This is my first run-through with the awards ceremony. I'm very excited. It's my pleasure to welcome you all here to our ceremony in which the National Academy of Sciences will recognize 22 individuals for their outstanding contributions to science. This year, the ceremony is being webcast live, and we welcome our viewers from across the U.S. and from abroad. The nomination details for awards to be presented in 2018 are available on our website. I encourage everyone to look there because we always are eager to see outstanding people nominated. The first prizes to be given are the Cozzarelli Prizes. During the PNAS editorial board meeting, 6 papers published in PNAS during 2016 were awarded the Cozzarelli Prize. The Cozzarelli Prize, named in honor of the late editor-in-chief, Nicholas R. Cozzarelli, is awarded to papers published in PNAS to recognize their outstanding scientific excellence and originality. The papers represent the 6 Academy classes. The full list of authors can be found in your program. I'd like to announce the prize-winning papers and ask the authors here today to stand and be acknowledged. So first of all is Class 1, the Physical and Mathematical Sciences. The authors are Sandu Popescu and Jeff Tolekson for the paper Quantum Violation of the Pigeonhole Principle and the Nature of Quantum Correlations. Congratulations. The second prize is in Class 2, Biological Sciences. Kanako Morohaku and Yanohi Obata for the paper Complete In Vitro Generation of Fertile Oocytes from Mouse Primordial Germ Cells. Congratulations. Congratulations to both of you. And the third is in Class 3, Engineering and Applied Sciences, Hao F. Zhang and Vadim Bachman for the paper Super Resolution Intrinsic Fluorescence Imaging of Chromatin Utilizing Native Unmodified Nucleic Acids for Contrast. Next is Class 4, Biomedical Sciences. The author here today is Jonathan E. Sears for the paper Comparative Systems of Pharmacology for HIF Stabilization in the Prevention of Retinopathy of Prematurity. Next is Class 5, Behavioral and Social Sciences. Fernando Colchero, Susan C. Roberts, and Roland Rao for the paper The Emergence of Longevous Populations. And finally, Class 6, Applied Biological, Agricultural, and Environmental Sciences. Russell W. Graham for the paper Timing and Causes of Mid-Holocene Mammoth Extinction on St. Paul Island, Alaska. So congratulations to all those winners. Next will be the Henry Draper Medal. There will be 2 recipients to be introduced at the same time, and they will be introduced by Netta A. Bacall, Chair of the Selection Committee. So Netta, please.
Einstein's beautiful sculpture in front of our building, as you know, always surrounded by visitors and kids, is a symbol for the importance and beauty of scientific discovery. As you all know, Einstein's groundbreaking theory of general relativity a century ago predicted the existence of gravitational waves, ripples in space and time generated by gravitational effects. These very feeble waves have never been detected until now. 100 years after Einstein's predictions, in 2015, the LIGO team, the Laser Interferometer Gravitational Wave Observatory, succeeded in detecting for the first time ever these waves. Waves that were generated 1.3 billion light years away from us by two colliding black holes. These waves traveled 1.3 billion years to reach us, shake our planet Earth, and distort by the tiniest amount the 4-kilometer-long LIGO detectors. It was not like an earthquake. It took the 4 kilometers long detectors by the tiniest amount, 10 to the minus 4 the size of a proton. So think about it. 4 kilometers long, 10 to the minus 4 the size of the proton, and that investigation and those instruments and those scientists succeeded in detecting it. This signal lasted only a fraction of a second and represented two 30 solar mass black holes, big black holes, spiraling in near the speed of light, merging into a 60 solar mass black hole and dying there. This trailblazing detection not only confirms Einstein gravitational waves and sees directly these black holes for the first time, but it also ushers a new field of astronomy. We can now observe the universe in gravitational waves, not just in the regular electromagnetic waves we are familiar with. I'm sure Einstein is smiling today. Check it out outside by the sculpture. This investigation and result is so important that you'll notice that the NAS has 2 awards today honoring different contributions to this project. This medal, the Draper Medal, honors the leaders who developed this amazing project for nearly 40 years. Later on, you'll hear from the NAS, the National Academy of Science Scientific Discovery Award, that will be honoring the current leaders involved in, as the name suggests, the scientific investigation. So the Henry Draper Medal today honors 2 outstanding leaders on behalf of the entire LIGO collaboration. Barry Barish, LIGO's early director, who brilliantly led the project from a small departmental experiment to a triumphant international collaboration through many ups and downs, and there were many of them, I remember them. And Stan Whitcomb, whose visionary leadership in developing the extraordinary instruments enabled this amazing detection. And let me read the formal citation. Honoring Barish and Whitcomb on behalf of the LIGO collaboration for their visionary and pivotal leadership roles, scientific guidance, and novel instrument design during the development of LIGO that were crucial for LIGO's discovery of gravitational waves from colliding black holes, thus directly validating Einstein's 100-year-old prediction of gravitational waves and ushering a new field of gravitational wave astronomy. Very important.
Well, personally, I'm humbled by this award, very happy to receive it with Stan Whitcomb, and want to acknowledge 3 different contributions to this amazing experiment. One is that there's not just Stan and I and the other recipients today, but 1,000 of us spread around the world, and it took this large collaboration and many years to succeed at this experiment. So we're receiving the award today, but it's really shared with a very large group of incredible scientists. Secondly, this took a long time, and we've been supported originally and consistently by our home institutions. It began with Caltech and MIT collaboration, an odd collaboration. And those 2 institutions have supported us with all our excessive demands for 2 or more than 2 decades. And lastly, I'd actually like to acknowledge something that I think matters for doing this kind of science, the ability to take on a large and very risky project that may or may not succeed was taken on by the National Science Foundation more than 20 years ago, committing enough funds to be watched by Congress all the way, and stood by us through more than 20 years before we've gotten our success, with very little to show along the way other than a lot of PhD theses and limits. So thanks to all of them, and I'm, as I said, humbled to be here.
Thank you very much for this great honor. As Barry said, the LIGO discovery was made possible by the efforts of more than 1,000 scientists, engineers, students, technicians, and many others working over there a long time, and their contributions should be remembered and recognized. I'm particularly grateful for the opportunity to have been given the opportunity to participate in this project over the past 35 years. And in particular, I'd like to thank Ray Weiss, Kip Thorne, Robbie Vogt, Barry Barish, the National Science Foundation, and my wife, Lori, not necessarily in that order, for giving me the opportunity to do this for so long. Thank you very much.
Next, we will have the NAS Award in Molecular Biology that will be introduced by Jasper Rine, a member of the Selection Committee.
The 2017 NAS Award in Molecular Biology is awarded to Rodolphe Barrangou of North Carolina State University for his landmark discovery that bacteria have adaptive immune systems, groundbreaking work that has catalyzed the manipulation of the CRISPR-Cas9 pathway for genome engineering. It is impossible to overstate the importance of the ramifications of these discoveries in experimental genetics and molecular biology, and increasingly in agriculture and clinical medicine.
Good afternoon, everyone. I am honored to receive this prestigious award, and I'm very thankful to a number of people. Firstly, I'm thankful to the NAS, the nomination and selection committees for their consideration, and also to Pfizer for sponsoring this award. This means a lot to me. It's a very big deal. Secondly, I'm very thankful to my colleagues, many colleagues, not as many as those colleagues. It didn't take as long, nor as many people, nor as much money, but it's a big deal nonetheless. And I thank all of them, many of them, my family, my friends, my mentors, Todd here in the audience, my wife Lisa as well. And they have inspired me. I think what's driven some of that effort is inspiration by a lot of other great scientists. And it's inspiring, and I can only hope to follow in their footsteps. And then lastly, I'm very thankful to CRISPR. If you've heard about CRISPR before, it's crazy. It's the CRISPR craze, and it's been a crazy ride for about a decade. Some ups, some downs, mostly ups, and it's been very enjoyable. And it's been amazing to see that in just 10 years, CRISPR has become what it has become, from very humble beginnings. And it's unbelievable to think that just 10 years ago, very mysterious DNA sequences in the genomes of bacteria that make yogurt would bring CRISPR to what it has become today. And I'm thankful for your consideration and thankful for the discovery. Thank you.
Next, we have the Gibbs Brothers Medal, which will be introduced by Rear Admiral Willard S. Firebaugh, Chair of the Selection Committee.
The 2017 Gibbs Brothers Medal is awarded to Jerome H. Milgram for wide-ranging original contributions to naval architecture in theoretical hydromechanics, education, yacht design, environmental protection, and the practical arts of ocean systems. Jerry Milgram's achievements in naval architecture and ocean engineering are wide-ranging and profound. More importantly, he sets the highest standard for dedication to principle in his technical work and as an educator. I'm privileged to have been his classmate in MIT class of 1961, and later to have had Jerry as a member of my thesis committee early in his extraordinary professional career. His pioneering work addressing the fluid mechanics of oil pollution in the ocean exemplifies how he readily accepts the intellectual challenges of the most intractable physics problems. In his work in the design of ocean racing yachts, he has pitted his skills as a naval architect in competition among the world's best. Jerry competes at the highest level as a scientist, a naval architect, and an educator. Surely the Gibbs brothers would have been particularly proud of this award.
I'd like to thank the committee for awarding me the Gibbs Brothers Medal. They attribute numerous contributions to me, but in reality, these contributions were made by my students and me. In addition to civilian graduate students working on projects, I had the benefit of students from the Naval Officers Engineering Program at MIT. These more mature students, mixed with the often more brilliant civilians, was a fantastic mix. And in retrospect, I can think of nothing better. Again, I thank the committee.
Next, we will have the Selman A. Waksman Award in Microbiology, which will be introduced by John Coffin, Chair of the Selection Committee.
The 2017 Selman Waksman Award in Microbiology is awarded to Bernard Roizman of the University of Chicago for his many seminal contributions to understanding the mechanisms by which herpes viruses replicate and cause disease. Actually, on a personal note, this is a great honor to me. This award has been given for many years, but the last time it went to somebody whose principal study was in viruses was in 1984. So, and nobody, I would think, deserves it more than Bernard, who's truly defined his field for a very, very long time. Unfortunately, Bernard is unable to be with us today, and Richard Whitley, his close friend and a collaborator, will accept the award on his behalf.
Needless to say, I'm not Bernard Roizman. Bernard is a dear friend, and he's been a friend and scientific colleague for 40 years. He cannot be with us today because he's tending to a terminal illness of his son and asked me to step in for him. If you know Bernard, he's a very soft-spoken person. He's not one for speeches. He would come up here and simply say thank you. So for Bernard, thank you.
Next is the Arctowski Medal. There are two recipients. They will both be introduced by Lennard Fisk, a member of the selection committee.
Thank you very much. On behalf of the selection committee, I'm very pleased to award the 2017 Arctowski Medal to Mats Carlsson and Viggo Hansteen of the University of Oslo. I'd like to begin by acknowledging the importance of this research for our understanding of the sun. For at least the last 15 years, Hansteen and Carlsson have been developing the Bifrost model, the world's best radiative MHD model of the lower solar atmosphere, the chromosphere, the transition layer, which controls the dynamics of the solar corona. And now with the availability of new observations, the application of the Bifrost model by Carlsson and Hansteen and by others is providing explanations of numerous solar phenomena that had been previously not understood. The work of Carlsson and Hansteen is considered to have led to the most important advance in solar physics in 30 years. And so let me read the citation. For their investigations of radiative transfer, magnetohydrodynamics, and plasma physics that has resulted in major advances in chromosphere diagnostics and our understanding of the physical mechanisms that drive chromosphere and coronal dynamics and energetics through to the development of the Bifrost numerical model of the sun's atmosphere, we're pleased to award the 2017 Arctowski Medal.
We are very pleased to accept the Arctowski Medal and award. Science is teamwork, and along the way, a great number of people have contributed to this work that's being honored. In particular, I'd like to identify Ege Lehr and Thomas Holzer, who at HAO taught me the importance of long-term planning in science. But they also taught me that being a scientist implies that you have to consider the fact that you are making mistakes, usually on a daily basis.
I'd like to thank my PhD supervisors, Bengt Gustafsson and Jonas Scharmer, for their inspiration and being eminent role models. We would like to thank Alan Teitel, Bart de Pontieu, and colleagues at the Lockheed Martin Solar and Astrophysics Laboratory for providing an environment for testing our models against the ground truth of solar observations. We thank the team in Oslo, in particular Boris Gudiksen, and we thank the National Academy of Sciences. We're deeply honored to be this year's recipients of the Arctowski Medal. Thank you.
Next is the Arthur L. Day Prize in Lectureship, which will be introduced by Turi Serling, Chair of the Selection Committee.
The 2017 Arthur Day Prize in Lectureship, and this comes as a lectureship, so the recipient makes a series of 4 public lectures in the next year. This year it's awarded to Susan Solomon of the Massachusetts Institute of Technology, and it's the committee notes that it's for her work in understanding atmospheric chemistry related to stratospheric ozone depletion and for leadership in communicating climate change science. It was Susan who demonstrated it was the chemical reactions in the stratosphere that led to the now well-known ozone depletion that we called the ozone hole. It was her scientific leadership that helped bring together 197 countries to sign the well-known Montreal Protocol, and that was the first universally ratified treaty in UN history. And this really demonstrates how people can work together for the common good. In 1986, she published a paper demonstrating the chemical reactions that were responsible for the ozone depletion. And 30 years later, in 2016, she published a paper demonstrating that the ozone hole is diminishing and well on the way to healing. Surely her example shows how individuals can make a difference to the world. Along the way, she's been able to write on popular science for the general public, and this includes a penetrating reconstruction of the weather during the ill-fated 1911-1912 Scott expedition. 100 years later, she spent a lot of time figuring out the details of climatology where no records were otherwise available, other than perhaps diaries and some other things. Indeed, as was noted in her letter of nomination, Susan Solomon is a special scientist and a special human being. Unfortunately, Susan is unable to be with us today. Ravi Shankara, Susan's close friend and collaborator, will accept the award on her behalf.
Thank you all. As you said, I'm sure you're all figured out I'm not Susan Solomon. The best thing I could do is I'm going to just read what Susan sent me. Madam President, ladies and gentlemen, I'm deeply honored by this fabulous award and apologize that illness has prevented me from being with you today. Because it's an award from the National Academy, that means coming from an organization that represents the finest scientists I know, and I can say is, hey, it doesn't get any better than this kind of a recognition from peers. I'm also delighted that the lectureship will give me a chance to talk to students about how much I have loved being a scientist. She really loves this, incidentally. I often strive to communicate to students how great a joy it is to be a scientist, not just because of the things you do, which are absolutely fascinating, the places you go, which are interesting, and in my case, even spectacularly beautiful, most importantly, because of the wonderful colleagues you encounter. Let me close by once again expressing my heartfelt appreciation. Thank you all.
Next is the National Academy of Sciences Award for Scientific Reviewing. It will be introduced by Charles F. Mansky, who is chair of the selection committee.
Thank you. The 2017 NAS Award for Scientific Reviewing, which this year is presented in the field of criminology, is awarded to Daniel S. Nagin of Carnegie Mellon University. Let me first read the citation. For exemplary reviews of the scientific literature in the crime prevention effects of criminal and social sanctions, these reviews have altered the course of criminological theory and empirical research and have greatly informed analysis of public policy. Let me say a few words about criminology. I think the Academy should be commended for choosing criminology as the designated field for this year's award, which is within the social sciences. Criminology is a highly interdisciplinary field. Criminologists study subjects ranging from basic aspects of human behavior to the operation of complex social systems to the practice of public policy. Perhaps because the field is so interdisciplinary, the NAS membership actually lacks a specific section on criminology. Hence, there can be a tendency not to appreciate the contributions of criminologists to the social sciences and to the nation. So it's laudable that the Academy is calling attention to criminology this year through the Scientific Reviewing Award. No criminologist provides a better exemplar for the field than Daniel Nagin, And let me add that a number of Dan's important contributions to criminology and synthesizing work in the field have been done through important studies right here at the National Research Council. If we go back to the late 1970s, Dan was instrumental in a landmark study on deterrence and incapacitation together with Al Blumstein, who's also here in the audience today. And then more recently, Dan chaired an NRC committee on deterrence and the death penalty in 2012. And that's a controversial subject, and that's also a really excellent report. So I'm very happy that Dan Nagin's getting the award.
Chuck, thank you very much for your kind words. I'd also like to take this opportunity to acknowledge Al Blumstein. Al was my PhD advisor, as was Chuck, it turns out. And he has now been my colleague for more than 30 years, and he's an important reason that I'm on the stage today receiving this award. The production of new knowledge and the synthesis of extant knowledge in the form of reviews are both creative acts in their own right. Most recognitions are in the form of rewards or elections to honorary societies are directed at the creation of new knowledge. This is as it should be, and I'm gratified to have received some of these recognitions. However, the importance of reviews in advancing science cannot be overstated. For this reason, all scientists should thank annual reviews for their sponsorship of this important award. It's hard to express my gratitude to Chuck and the other members of the selection committee for adding me to the roster of the distinguished scholars who have preceded me in receiving this award.
And now it's time for the National Academy of Sciences Award in Chemical Sciences, introduced by James L. Skinner, Chair of the Selection Committee.
It is my great pleasure to present the 2017 NAS Award in Chemical Sciences to Paul Alivisatos, Samsung Distinguished Professor of Nanoscience and Nanotechnology and Vice Chancellor for Research at the University of California, Berkeley. The citation reads, "For making fundamental contributions to the controlled synthesis of colloidal inorganic nanocrystals, measuring and understanding their unique physical properties, and utilizing these properties for applications ranging from light generation and harvesting to biological imaging." The importance of Professor Alivisatos' pioneering nanoparticle synthesis, characterization, and applications has been stunningly profound. In addition, he has been an excellent mentor to over 150 graduate students and postdocs. He has been an entrepreneur, having started 2 extremely successful nanotechnology companies, and he is the founding editor-in-chief of the ACS journal Nano Letters. Finally, he has been an enormously effective and consequential academic and intellectual leader at both the Lawrence Berkeley Laboratory and UC Berkeley. He is, without a doubt, eminently worthy of this award, and I am deeply honored to present to you Professor Alivisatos.
Thank you so much. What a great honor. I'd like to acknowledge the support of my spouse, Nicole Alivisatos. There is a wonderful community that has developed over some decades that, like me, appreciates the beauty of small crystals, which are a playground for new understanding and for study, but also for practical application. So I'd like to thank the community of science that I've been a part of and that leads to this recognition. And finally, I'd like to acknowledge 2 phenomenal institutions where the concept of seeking new knowledge to the benefit of the public is at their core.
University of California, Berkeley, and the Lawrence Berkeley National Lab. Thank you.
Next, we have the Richard Lounsbury Award, which will be introduced by Leslie B. Vosshall, Chair of the Selection Committee.
On behalf of my chairs, on behalf of my committee members on the Lounsbury Award, I introduce to you Pardis Christine Sabetti. She is a one-of-a-kind scientist, an exceptionally creative researcher with a deep commitment to mentoring, open data sharing, and promoting capacity building in the developing world communities where she and her collaborators do their important work. Pardis was at the center of the devastating 2014 Ebola outbreak in West Africa. Her team tracked the spread and rapid mutation of the Ebola virus as it surged across local villages and national borders. These results are critically important for genomic surveillance of the virus and for developing effective diagnostics, vaccines, and antibody-based therapies. This was brave and dangerous work. Tragically, several of her co-authors on the science paper that reported these results had succumbed to the virus by the time the paper was published. I'd like to present the 2017 Richard Lounsbury Award to Pardis Christine Sabetti of Harvard University for groundbreaking contributions to genetics and global health, including development of new methods to study evolutionary selection in humans and viruses, creation of new collaborative models for combating emerging diseases across disciplinary and national borders, and leadership of global efforts to increase data sharing in pandemics, including Ebola and Lassa fever.
Thank you. Thank you to the Lounsbury Foundation for connecting the U.S. and France through science, and for this award that I humbly accept on behalf of my students and colleagues. Also, the National Academy of Science and the Académie des Sciences for your leadership in a challenging world. And to the Selection Committee, Leslie Vishal, Laura Hooper, Angelica Amon, Neil Shubin, and Barbara Meyer. These are individuals who I aspire to be like as scientists and as human beings, and I am humbled by your kindness. I'm here today with my mother and father, who instilled in me their values to be on this earth to help others, my sister, my earliest and most dedicated teacher, who also brought me my two greatest joys, my nephew and niece, Tovi and Zia, and my kind and gracious Aunt Nusheen. I'm grateful to my family and to my many teachers and mentors throughout my life, including my academic mentors, Dave Bartel, Rick Ward, Dominic Kwiatkowski, Diane Worth, and Eric Lander. I have one of the greatest vocations on this earth because of the wonder in science that they instilled in me and the community around it that my lab and my colleagues and other students and friends have created. They inspire me every day with their brilliance and their work ethic and their desire to help others, and they make me laugh and smile through the most challenging of circumstances. I'm very honored that they have shared with me their journeys, and I hope to stand by them as they have always stood by me. Thank you very much. Viva la science.
Next is the Trollin Research Awards. This year there will be 2 awarded, and they will both be introduced by Brian A. Wandel, a member of the Selection Committee.
Thank you very much. The Trollin himself was a polymath. He was a person who got his degree in biochemistry and studied vision science and studied motivation, and was actually the leading engineer in Technicolor that brought us color movies. And when he initiated this award, it was for young people in experimental psychology. And indeed, we're very pleased. One of the great honors to serve on this committee is to see about the vibrancy and excitement of the young people, and we're lucky to have two outstanding awardees this year. The first one that I would like to introduce to you is, I should say, young is crisply defined as 40 or younger, and I think that works for most of us in this room. I'm first very pleased to introduce Tim Behrens from the University of Oxford. The citation on Tim's award is for his outstanding research into the brain systems, neuroanatomical systems mediating learning and decision-making. And I should say that the committee was also very admiring of the breadth of Tim's contributions, including computational methods, software development, bringing together many different groups. And so with that thought in mind, honoring Troland, Tim, please come on up.
Thank you very much. I'd like to thank the National Academy of Sciences, and particularly the Troland Award Committee. It's an honor to be associated with a list of extraordinary scientists that have won this award, including now Sian. It's particularly generous that the award is shared with foreign scientists as well. The US is once again supporting science globally, where other countries might take a more parochial view. If I've had any success in science, it comes from finding clever friends and riding on their coattails. I'm fortunate to work in Oxford and London, where many people wear coats with long tails. Matthew Rushworth, Heidi Johansenberg, and Steve Smith have carried me particularly far, and my amazingly talented group are still carrying me now. Lastly, I'd like to thank the Wellcome Trust for funding me, and my family for putting up with me. My sister Gina is here today from Boston, and my parents, wife and kids are struggling at home to make the webcast work. Thank you very much indeed.
Thank you, Tim. It's now my pleasure to introduce Sian Bailak. And Sian is also extremely broad in her interests, and the citation of her award is for her fundamental contributions to our understanding of human skill learning and performance breakdowns in high pressure and anxiety-provoking situations. And this might be one of them for you, I'm not sure. But and Sian, like Tim, Sian has reached very, very broadly from the basic understanding of the human mind. She's also worked in neuroimaging, and she is very active in reaching out into the community in school systems and looking at interventions and trying to improve the lives of families. And so with that, congratulations, Sian, and please come back.
Thank you. It's really an extreme honor to receive this award, and like Tim, I'm humbled by the scientists who've received it before me. I'd like to thank my PhD advisors, Tom Carr and Deb Feltz, who taught me about rigorous scientific inquiry and the value of questioning others, but most specifically questioning myself and my assumptions. I'd like to thank my lab at the University of Chicago. All the work I do is truly a team effort, and also the National Science Foundation and the Department of Education for the funding I've received throughout my career, which allowed me to do the work that I've done. And finally, I'd like to thank the National Academy and the Troland Award Committee. I see this award in particular bestowed on myself as a recognition of the value of basic social science research, but also the value of translating that work for a broad popular audience. Thank you very much.
And now we have the National Academy of Sciences Award for the Industrial Application of Science. This award will be introduced by Robert E. Kahn, Chair of the Selection Committee.
Okay, thank you. This is an award that is given out for original scientific work that has intrinsic scientific importance and significant beneficial applications in industry. tough combination. In previous years, different areas were selected. This year's award honors research that was done in the field of computer science. Let me say that that field, as most other fields, is fairly large, and you can look at it in very different ways. But the particulars about computing that we were looking to honor were the ones that had clearly demonstrated importance in the external community based on what industry had done as a result of this scientific research. So the award for industrial applications of science in the field of computer science is awarded to Robert H. Lennard of the IBM Thomas J. Watson Research Center for seminal contributions in the field of microelectronics for the invention of dynamic random access, DRAM, memory, and CMOS scaling. Now, just to put this in context for you, the notion of computing really, in many people's view, comes out of mathematics and logic, although it's been driven by industrial applications subsequently. But, and for many people, it goes back to the work of folks like Alan Turing and others. But in order to develop practical applications of it, you really need to have the computing technology be manufacturable and presentable, and to get practical and economic implementations of this were really the challenge. This work that Bob Lennard did in inventing the dynamic random access memory made it possible to take notions of processing in memory and turn them into real activity. Now, if you note on the program, you will see that this award was established by IBM in honor of Ralph Gomery, who I know is here today because I saw Ralph earlier. I have no idea if he's in the audience. There he is down there. Ralph is a friend for many years, but in full disclosure, I did not know that this award was established by IBM or in his honor until just this morning as I took a look at the program. So the fact that IBM established it and it's going to somebody from IBM is an absolute circumstance of history, is what actually happened. Unfortunately, Bob Lennard wasn't able to be here today. What he told me was he had a serious health issue that involved surgery and a long-term recovery. I know he's communicated that as well to the Academy, but they gave him an opportunity to do a video or have somebody else show up. He asked me instead to just read a few acceptance remarks. What he said was, I'm very grateful to NAS for selecting me for this prestigious honor. The level of success that DRAM, dynamic random access memory, has achieved is due to a steady influx of new ideas and improved technology over more than 40 years from, again, thousands of people throughout the world. I'm amazed at how far DRAM and CMOS scaling, which was critical to make sure it would continue to be useful as the technology scaled, have gone, and how much of our lives have been impacted by the resulting growth in computing capability. The work I'm being honored for came out of programs at IBM Research with well-defined, ambitious goals, which involved a lot of teamwork. I want to acknowledge the contributions of my associates to the success of those programs. Particularly, I want to mention Dale Critchlow and Louis Terman for their leadership, and my coworkers in scaling, namely Fritz Gainslen and YU, for showing that scaling was much more than a theory. And thanks again to NAS for this great honor.
And now it's time for the NAS Award for Chemistry in Service to Society. This award will be introduced by John C. Tully, Chair of the Selection Committee.
Thank you. The 2017 NAS Award for Chemistry in Service to Society is awarded to Leroy E. Hood of the Institute of Systems Biology. The citation reads, for his invention, commercialization, and development of multiple chemical tools that address biological complexity, including the automated DNA sequencer that spearheaded the Human Genome Project. So the emphasis, or an emphasis of this award, is on service to society. It is a great pleasure to present the award to Lee Hood, whose amazing contributions have so profoundly changed the way, have changed our lives. Thank you.
I went yesterday with friends and family to the Lincoln Memorial and was really struck by the words behind the city in Lincoln. His memory forever enshrined. And my feeling is that's exactly how we should view science today. It should be enshrined in the hearts and minds of our different citizens. For science gives us the ability to distinguish truth and falseness here and abroad. It gives us the ability to take on the enormously challenging problems of the world and of society, global climate change, and my interest, healthcare, and solve them. It gives us the ability and appreciation for the beauty of the natural world to enrich our souls and the souls of future unborn. It gives us the ability to stimulate our students to take on a challenging, ever-changing, dynamic career that will make them be the best that they can possibly be. It acknowledges the enormous power of diversity, human diversity, both in immigration and internal heterogeneity, and the power it has for changing our world. And it also gives us the opportunities to think fundamentally about inventing the future, about giving our citizens a kind of life that can enrich and enable and let people fulfill the potential they have. So I'd just like to say again, I think science must be enshrined in our hearts and our minds for the future, for science is the key to inventing a future that has power, beauty, simplicity, and the ability to let all of us reach our potential.
And now we have the Pradell Research Award, which will be introduced by Li-Ching Liu, Chair of the Selection Committee.
It's my honor to present the 2017 Pradell Research Award to Karl Svoboda of Howard Hughes Medical Institute for his pioneering work to develop techniques for imaging cellular and synaptic structure and activity in the brain, and for using these methods to obtain insight into how the brain represents and stores information about sensory stimuli and transforms such information into action during motivated behavior. On a more personal note, I had a pleasure about 10 years ago to co-author a review together with Carl and another colleague, Ed Calloway at Salk Institute, on a genetic analysis of neural circuits, where over a few intense months, I learned a tremendous amount from Carl about his intensity, his insights, and his precision of thinking. And we are now doing a 10-year anniversary piece, and I look forward to learning a lot from Carl again.
start. Well, thank you to the Pradel Committee for this honor. I'm humbled. The award is for high-resolution imaging of neural structure deep in the brain, and my laboratory's achievements are really in great part, really about being in the right place at the right time. And in particular, I was at Bell Laboratories when a revolution in biological imaging happened, and I have to acknowledge with gratitude the mentorship of David Tank and Winfried Denk in those days. And then that revolution continued with many other collaborators at Cold Spring Harbor Lab and at Janelia Research Campus now at Howard Hughes Medical Institute. And I've also been incredibly lucky to be at these institutions, at places for science that provide freedom, long-term support, and excellent infrastructure for research. And that's a very rare combination nowadays. And I'm really privileged to have been working at these places. Of course, most important are the many collaborators and colleagues who pushed us to do better science. Finally, I'd like to acknowledge my alma mater, Cornell University, where the early switches for a career in science were set. I had unusual opportunities to immerse myself in research early on, and with appreciation, the Pradel funds will go to Cornell University to support opportunities in undergraduate research in the area of neurotechnology. So thank you again to the committee and all of you.
Next up is the National Academy's Award for Scientific Discovery. The 3 awards will be introduced by Louis E. Brust, Chair of the Selection Committee.
This is the award for scientific discovery in basic research. This year the choice is, the field is narrowed to physics and material science. There are 2 criteria for this award. 1, the award must be for discovery given in the last 5 years, made in the last 5 years. Second, the discovery must be so important that it's likely it will appear in undergraduate textbooks in a short time. So with this as a background, you can understand why we now come to the second LIGO award of this afternoon for the direct detection of gravitational waves, confirming Einstein's prediction. The 2017 NAS Award for Scientific Discovery is awarded to Gabriela Gonzalez of Louisiana State University, David H. Reitze of the California Institute of Technology, and Peter R. Salson of Syracuse University for outstanding leadership of the large international LIGO scientific collaboration, bringing together all the necessary elements, the instruments, the data analysis, general relativity, and astrophysics for the first direct detection of gravitational waves. Thank you.
It's an honor to be here receiving this award, and we thank the Academy and the committee, especially for explicitly giving this award, recognizing teamwork. This result, this incredible result, has been thanks to the effort of not just the more than 1,000 people working in the field now, but the many other people who built this field in the previous decades and are working all over the place. This is a collaboration that broke barriers, geographic barriers, age barriers. We all work together in different institutions, small and large, different countries, different cultures, and we get along. And we produce results. I want to thank again my predecessors and the National Science Foundation for supporting not just the LIGO laboratory, but many other institutions working in this field in the US. And on a personal note, I want to thank my academic mentors, Ray Wise, who was also the first spokesperson of the collaboration and is not here, Peter Solson, my PhD advisor, and my family, who, far from Argentina, supported me all the way from the beginning, and my husband especially, who is here and has been a great support through all the ups and downs in life in this project. Thank you.
Thank you. I'm, like others, I'm deeply grateful to be recognized for this award, and you'll hear a lot of common themes from those of us who are representing LIGO. It really is a team effort, and so while I get to stand up here, others get to stand up here and be recognized, there's really a lot of people that made this work. And I'm going to point out a few names you haven't heard of, but I think they're important. Dennis Coyne, Chief Engineer of LIGO, Peter Fritchell, Chief Detector Scientist of LIGO, Fred Robb is the Hanford Site Head, and Albert Lazzarini is the Deputy Director. These people have all just been amazing in the way they've been able to pull this project along. I first heard about LIGO 20 years ago, and when I heard about it that you could detect black holes colliding by measuring something tiny fraction of the proton, I thought it was crazy. But I also thought it was worth getting involved in because it was really challenging, and it turned out to be true. I think we have to really acknowledge that this is a really hard project. Einstein predicted these effects 100 years ago, and it took us that long to do it. The National Science Foundation has been with us through thick and thin, and we would not be here today if it weren't for the vision and the leadership within the National Science Foundation. So thank you. Finally, one word. My wife is here with me, and I really have to thank her. She has been a very steadfast supporter of my career. So much so that she had to be in Los Angeles yesterday for something, so she took a red eye to be here tonight with me. So thank you very much.
When I went to work for Ray Weiss as a postdoc in 1981, I hoped that somehow something scientifically glorious would come of it, and now it has. Thank you, the selection committee, for this honor. The National Academy is doing a really wonderful thing here. So pleased that Barry Barish and Stan Whitcomb have been recognized with the Henry Draper Medal for their irreplaceable contributions to LIGO's success. And my sharing of the award for scientific discovery with my first and favorite student, Gabby, my good friend Dave, goes an important step further. As they've emphasized, it constitutes a recognition that it really takes a village to accomplish something as glorious as LIGO. It took the leaders, Ray, Kip Thorne, who's here, the late Ron Drever, who unfortunately can't be here, all of our institutions, the U.S. taxpayers whose support was shepherded so well by the National Science Foundation. But it also took the village called the LIGO Scientific Collaboration. For me, it also took my beloved wife, Sarah, whose love and support have been profound and irreplaceable. Thank you all.
Next, we have the Raymond and Beverly Sackler Prize in Convergence Research. This will be introduced by Monica Olvera de la Cruz, Chair of the Selection Committee.
The 2017 Raymond and Beverly Sackler Prize in Convergence Research is awarded to Frances Arnold of the California Institute of Technology. Frances is a member of the 3 national academies that already demonstrate that her impactful research, revolutionary ideas had been possible through the convergence of fields and disciplines. The award, she's awarded the Sackler Prize for her pioneering directed molecular evolution strategies used worldwide to optimize the functions of enzymes and to engineer cells to produce biofuels and chemicals from renewable sources. Directed evolution is based upon the concept the concept that the desired biological trait can be obtained through iterative cycles of mutations and screening. Frances showed that beneficial mutations can be accumulated and better enzymes obtained by the iterative application of random mutagenesis and high throughput screening to identify rare, good mutations. Frances' pioneering work in directed evolution lies at the heart of nearly all technologies that utilize biological processes for the conversion of agricultural products into fuels and chemicals.
Convergence, I know you're wondering. In my experience, convergence research results in those papers that no one wants to review, makes editors tear their hair. Well, I use evolution. Evolution in sex, that is mutating and recombining genetic material to make new biological molecules. And that way we can actually explore beyond nature and use biological systems to solve human problems. Of course, with the same is true as interdisciplinary research. Not all recombinations are that good an idea. Recombining monkeys and worms is not likely to lead to a very handsome child. But we are delighted when we occasionally discover that this evolution in the laboratory generates novelty, useful novelty, including progeny molecules that can do things their parents cannot do. And if you don't believe that, just ask your children. Recombination can do that. Humor aside, though, I see every day that the ability of biological systems to adapt to a highly competitive and rapidly changing world rests squarely on genetic diversity. And I think that we, and especially our leaders, have a lot to learn from how nature innovates. Without diversity, we all move down exactly the same path, and we accumulate a lot of really wrong ideas. And so I thank the National Academy of Sciences for this wonderful prize, the Sacklers, and especially my students whose discoveries every day make science a joy. Thank you.
And now we have the Academy's newest prize in Food and Agricultural Sciences. It will be introduced by Barbara Shaw, Chair of the Selection Committee.
This is the first awarding of the National Academy of Sciences Prize dedicated to food and agricultural sciences. The prize was established by the Foundation for Food and Agriculture Research with support from the Bill and Melinda Gates Foundation. The prize will be given annually, and it's for extraordinary contributions to agriculture or to the understanding of the biology of a single species that is fundamentally important to agriculture. And it's part of the Foundation's efforts to elevate food and agricultural research in the scientific arena and to highlight the critical need for scientists working towards more productive, sustainable agriculture and the better health through nutritious food. The first NAS Prize in Food and Agricultural Sciences is awarded to Dr. Edward S. Buckler of the U.S. Department of Agriculture, Agricultural Research Services. This is an extraordinary person to be the very first for this award, and he really sets the standards for all future awardees. He is receiving the award for insights and discoveries that changed our understanding of quantitative genetics, for facilitating genetic characterization of genes underlying critical traits and their deployment for breeding programs in a myriad of species, and for truly exemplary collegiality and sharing resources for the betterment of crops and the human condition.
So first off, I want to thank the National Academy and the Selection Committee for this incredible honor, and for the Foundation for Food and Agriculture and the Gates Foundation for making the prize available and for future people to receive it. At an early age, I got from my parents the real passion for computers and for biology. But then over the last 2 decades, it's been my wife and my son who've been the sounding board for my crazy ideas. And I can't do without them in this. But then it took great teams. First, I had a series of wonderful mentors, and then I've had great teams and collaborators at the University of Missouri, North Carolina State, Cornell University, and the USDA. And I now have a list of about 500 or 600 global collaborators who help make this possible. And they've all been supported by efforts like the National Science Foundation, the USDA, and the Gates Foundation, as we all work together to make these teams to try to change our food production systems. We're at a point now where genetics has incredible power, and now we really need to address these global problems of how to really feed the world over the next 50 to 100 years in a sustainable fashion. But we have the technology, and now it really takes the teams and effort and inventiveness to design new production systems. So I thank everybody for the award. Thank you.